Hello all. This video I'm going to give you a walkthrough of these multiple hub and spoke topology where customers will typically look for network isolation, segregation in OCI and how we can get that configured using a single DRG, a prod hub VCN and prod VCN spoke, and you will also have a non-prod VCN hub and a non-prod VCN spoke. So the prod, as the name suggests, prod VCN spoke will be able to access anything using prod VCN hub, whereas prod VCN's non-prod VCN spoke needs to go to non-prod VCN hub to get any access, be it internet or going to on-prem networks. And these are the two on-prem public IP address locations. So for the sake of the lab, I created an IPsec VPN tunnel with these remote locations, and you'd see two highly available tunnels configured for both on-prem A and on-prem B. And if you click open, you would see both tunnels up. So I've terminated IPsec connection to these, and on-prem B is 172.16.1.0, whereas on-prem A CIDR range is 172.16.0.0. And the instances I have a prod web server and a non-prod web server, a public load balancer, which front-ends this production application and non-prod application. So if you have gone through the network flow diagrams, you would know that there is a load balancer deployed for the production application, and there's a separate load balancer deployed for the non-prod application. And when I'm trying to access the website, it's a dummy website. So you would see this is my test prod web server running on Oracle Cloud Infrastructure. That's the message. And when I try to access the non-prod web server, you should see this message. This is my web server running on Oracle Cloud Infrastructure. This is my non-prod web server. So these north-south traffic flow is pretty straightforward. I mean, it's similar to your the one that is covered in the scenario one, which is hub and spoke topology, whereas the traffic comes from the internet. When the traffic comes for the non-prod workload, when it comes from the internet, the traffic hits the IGW, and then it's forwarded to the public load balancer. The load balancer forwards the traffic to the firewall here. The firewall inspects the traffic and sends the traffic to the non-prod VCN spoke through its DRG attachment. That's the flow for ingress. So likewise, when I'm trying to access a prod application, the traffic goes through this, comes to the internet through the internet gateway, gets inspected, and goes to the prod VCN firewall. You should be able to validate if your DRG routing configuration is right by going through the network visualizer diagram. So if you see here, the prod VCN hub, if you select this connection, you would know that it is able to connect to prod VCN spoke and on-prem networks. And likewise, the non-prod VCN hub will have connectivity to on-prem networks and non-prod VCN hub. But these two networks are segregated. You'd be able to see that just by looking at the connections in the network visualizer. Now, let's see how it is configured. If we go to the DRG, we have 4 VCN attachments. You would see a hub routing table for prod and non-prod hub routing table for the non-prod hub VCN. And there's a routing table for the spokes meant for the non-prod spokes. And there is a spoke routing table that's meant for the prod spoke. So let's quickly take a look at the prod hub and non-prod hub routing tables, which is meant for the two hubs that we have in this topology. So if I click open the prod hub routing table, there is no static configuration. There's just one import route distribution that is configured. Let's see what that import route distribution is. So import route distribution is a method which lets your data route table to import routes automatically. So you don't want to have static routes in your hub routing table, right? So you kind of basically tell your broad hub routing table what routes it can actually learn. So this prod hub can learn any network that is going to come out of the prod VCN spoke attachment, and it is also learning your IPsec tunnel attachments. So let's say if you also have fast connect or an RPC, and you want your hub to inspect all those traffic, then you would also want to attach them in this import groups, and then your prod hub would start learning them automatically. So you use this, create this import route distribution, create a routing table, and import that in your the prod hub routing table. So the non-prod hub routing table would look similar. It's just that it will have a different import route distribution, and it would only import non-prod VCN spoke, as you can see here, and it is importing IPsec tunnel. So basically, the non-prod spokes, the prod hub will only know the non-prod spoke VCN and the on-prem network attachment route tables. Now let's see the spoke routing tables, which is pretty straightforward, because the spokes can have only one route, which is pointing to the which will get forwarded to the hub. So any traffic that's coming out of the prod spoke uh, attachment will have a routing table attached in the DRG, which says default route will be forwarded to the prod VCN hub attachment. And similarly, you would also have a non-prod spoke routing table, which will have a similar routing table. So this, but then it would go to a non-prod VPN, prod VCN attachment. The IPsec tunnel attachments, it has only one routing table configured. And if you see, and the routing table entry says 10.1 network and 10.0.0 network are being forwarded to the prod VCN hub attachment. So 10.2 network and 10.3 network are being forwarded to the non-prod hub VCN attachment. And that's precisely why the on-prem IPsec attachments are able to only make this connection to the hubs, prod and the non-prod hub, and not to the spokes directly. So we are essentially hiding the spoke networks from IPsec tunnel attachments, and that's why we are able to see the traffic going to non-prod and prod VCN hubs respectively. So with the routing tables, we are able to kind of understand that the prod VCN spoke can only connect to the non-prod, and the IPsec attachments, it can only connect to the two hubs and not to the spokes directly. And the hub are the only connection which is able to connect to both on-prem and spoke. However, it is not able to connect to other prod VCN hub or prod VCN smoke. So we basically achieved the segregated network with using a single DRG. This is my on-prem A host. I have a server which is deployed in on-prem A, and I have a server deployed in on-prem B. Assume that these are two different servers, and they are able to access. Let me try to do a curl of prod web server from. So if I try to do a curl from my on-prem A network, then I'm able to get access the web page just fine. It returns 200 OK. And let's see if I'm able to access the non-prod web server. Curl hyphen v http 10.3.0.108. Yeah, there you go. I'm able to access even that page just fine. And let me also show you if I'm able to access the same two servers from my other on-prem data center. So I will curl the website again, 64. Yeah, I'm able to access prod web server from on-prem B. And I will also be able to access . yeah, the non-prod web server is able to also access this. So now we are able to access both servers, and it is going through two different hubs, and a firewall obviously deployed in these hubs. Now let's say I want to uh, make a change in this topology. Um, if in another scenario, you might it might be an ISV. You may be an ISV who wants to have um, multiple customers data centers, and you want those customer data centers to be connecting to their respective workloads. Say you want on-prem A to connect. You want on-prem A to connect to only prod workloads, and on-prem B to connect to only non-prod workloads. Then how can we achieve it? That's simply by making some changes in the DRG routing table. You go to the DRG routing table, you create uh, a route table that's meant for on-prem A IPsec attachments, and you simply only include the prod VCN. So if you remember, the IPsec RT route table had prod and non-prod net CIDR ranges, and it was forwarding the traffic to both prod and non-prod hubs. But here I've just removed non-prod VCN hub attachment for on-prem A. Likewise, I've also created another route table for on-prem B, where I've removed the prod working VCN attachments. So by making this change, by creating this route table and attaching this route table to the IPsec VPN tunnel attachments. So let's say I have this is IPsec on-prem A tunnel 1. So let me go and reconfigure this IPsec to on-prem A that I created. And let me also change the tunnel 2 of on-prem A, which is this, as a name. So naming it appropriately will make your life easy. So that's another tip. So IPsec RT on-prem A. Likewise, you change the route table that you configured from on-prem B. On-prem B is also changed with that. Now the prod hub, the spoke routing table remains the same because it's not changing. It has to send the traffic to the same non-prod hub, and the prod spoke has to send the traffic to the prod hub, right? So non-prod hub routing table, we create a new import route distribution called non-prod hub V2. And here, the earlier routing table was importing non-prod spoke VCN and also all IPsec tunnel attachments. But then now we've changed that, reconfigured it to tunnel 1 and tunnel 2 of on-prem B. This is for non-prod. Likewise, you would have an import route distribution for prod, which will be tunnel 1 and tunnel 2 of on-prem, and it is importing. So I've basically created two new import route distribution. And what we will do is we'll just make the route table use a different import route distribution. So if I go to the DRG route tables, the route tables are attached to the VCN attachments. We will see that it is non-prod prod VCN hub attachment, which is hub routing table. Here we're seeing it is using our prod hub import route distribution, which is this. I'm going to simply change that import route distribution from prod hub to prod hub version 2. Similarly, you would make a change to the non-prod hub routing table, which is using this import route distribution group, non-prod. I'm going to simply change that to non-prod hub version 2. With that change, let's see how the network visualization looks like. If you see on-prem A IPsec, it has attached access only to the prod hub VCN. And on-prem B will have access only to the non-prod hub VCNs. And non-prod hub VCN has only access to the on-prem B, and a prod hub VCN will have access only to the on-prem A. So if with this kind of setup, now I'm trying to access this on-prem from on-prem A, I'm trying to access the prod hub, the prod spoke workload. Say I'm able to access the prod workload server fine, and I should not be able to access the non-prod server anymore. There you go. Now it has stopped working just because we made those changes to the DRG routing table. Now I'm not covering the transit routing that is required in the hubs. Hub VCNs and the spoke routing table are just similar to the scenario one. So I'd recommend you to thoroughly understand that flow. Now I will also show you the on-prem B server and show you that I will be able to access the same non-prod web server from on-prem B just fine, because that's how we configured the routing table. Now, if I try to access the prod workload from here, it will stop working. We were able to achieve this segregation purely with a single DRG. I hope you find this video helpful.